my dear students. Once again, welcome back for chemistry online class. Today we shall be in new chapter in chemistry, that is chapter 5, the periodic table. And today we shall just discuss about the general idea of Dobinet's friend and Newland's law of octets. For this, you can refer to page number 86 and 87 in your textbook. First of all, I would like to ask you a simple question. Why do we classify things? Answer is simple. Because classification makes our work easier and systematic. As you know that at home, your mother keeps your clothes in almirah according to the varieties of your clothes, which makes your work easier and systematic. Similarly, if you go to medical store to buy medicine which is prescribed by your doctor, shopkeeper brings medicine within a fraction of a second because they have arranged the medicine in such a way. They have arranged the medicine of various diseases which makes their work easier and systematic. If those medicines are arranged in a haphazard way, their work will be very, very difficult. So it is necessary to classify elements. As you can see, your classification of elements. Many attempts were made by different scientists in order to make their study easier and systematic. All chemists, person who deals with chemicals in the early ages, they classify the elements as metals and non-metals. Metals further classified as noble metals and base metals. Noble metals are precious metals like gold, platinum, silver. Base metals are cheap metals like iron, copper, etc. Now here, next after this alchemist J.W. Dobiner, in 1870, he arranged the elements in group of 3, which is known as Dobinet's triads, and he found that the atomic mass of middle element is approximately equal to the average atomic masses of other 2 elements. As you can see your example, lithium, sodium and potassium. It is an example of Dobinet's triad. Lithium atomic mass is 7, sodium is 23, potassium is 39. Here the middle element is sodium. Now average atomic masses of this lithium and sodium, potassium. 7 plus 39 over 2, 46 over 2 is 23. 23 is the atomic mass of sodium. So here Dobinet's triad states that when the elements are arranged in group of 3 and the atomic mass of middle element is approximately equal to the average atomic masses of other 2 elements. Now next, your drawbacks of Dobinet's triads. Defects. Dobinet failed to arrange all the known 63 elements in group of triads. Although he got some success, however, the idea of classification of elements according to triads could not be applied to all the known elements. This was the first defect. Now second one, this idea of classification does not work in the same group as in the case of halogen. Here, fluorine, chlorine, bromine. Here, fluorine atomic mass is 19, chlorine is 35.5, bromine is 80. Atomic masses, average atomic masses of fluorine and bromine, 19 plus 80 over 2, 99 over 2, then 49.5 is the average atomic masses of these 2 elements. This 49.5 is not equal to 35.5. So here this classification, this idea of this classification does not work even in the same group. Now next, Newland's law of octet. John Newland Newland was an English scientist who was a lover of music. In 1864, he arranged the elements in the increasing order of the atomic masses, and he observed that the properties of first element resemble with the properties of eight elements, since it is the repetition in the properties of elements, just like repetition in the octave note of music. It came to known as law of octaves. Based on this observation, John Newland gave law of octaves or classification. Now here this law states that when the elements are arranged in the increasing order of their atomic weight, the properties of eight elements are similar with the properties of first or starting element. As you can see here, this I already explained you. Here John Newland was the lover of music. Now here do, re, mi, fa, sol, la, ti. This is musical note in Western. See here, first element hydrogen. Here according to Frobenius law state that when the elements are arranged in the increasing order of their atomic weight, here the properties of eight element are similar with the starting element. First, second, third, fourth, fifth, sixth, seventh, eighth. The properties of fluorine are similar with the properties of hydrogen. Now if you start from beryllium, 1, 2, 3, 4, 5, 6, 7, 8. The properties of magnesium are similar with the properties of beryllium. Here, John Newland's law of octaves states that when the elements are arranged in the increasing order of their atomic weight, the properties of eight elements are similar with the properties of first element or static elements. Same way here, nitrogen, if you start from the nitrogen, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. The properties of phosphorus are similar with the properties of nitrogen. Now, drawbacks of Newland's law of octaves. Here, after the discovery of noble gases, the idea of octave did not work. Here, neon comes between fluorine and sodium, and argon comes between chlorine and argon comes between chlorine and potassium. Here, after the discovery of noble gases, the idea of octaves did not work. Now next year, the classification failed. This classification failed with regard to heavier elements. That is, it works well till only potassium. It does not work or did not work beyond this calcium. As more and more elements were discovered, they could not be fitted in Newland's law of octaves. Here, more and more elements were discovered, and this element could not be fitted in Newland's law of octaves. Dear children, here we have come to the end of today's online class. Thank you very much.